Recording? All good?
All good.
Excellent. Right. Hello, everyone. Thank you very much for having me. First part of this talk is basically a quick disclaimer. This is not a talk about in-depth detailed exploit techniques. This is a talk about common failings, things that developers do that allow malicious actors to do what they do, because that's the kind of low effort, high return work that attackers like, but also us developers often like because we're all lazy, let's face it. Right, I am Brunty. I'm a developer. I work with a company where we are building a new generation of capture the flag technology and a platform where effectively the cool sort of title is hackers use it to compete against each other. The other alternative approach that my team leaders often mentioned is it's like a question and answer system, but that's not quite as exciting. So we go down the hacker competition route because that's a lot more fun. I'm a mentor and a mentee. I like teaching other people as well as learning myself. I find great value in teaching junior and more sort of apprentice level developers in my past. And I learn a lot from them as well because sort of fresh brains can bring some really good new questions and new approaches to things rather than the kind of seasoned old hats that have been doing it for 30 years and kind of go, well, that's just the way it's always been done. And at heart, I'm a tinkerer. I like poking around code. I like poking around with home automation stuff. I like peeling things apart, seeing how they work and trying to put them back together, often unsuccessfully. So when we consider hackers, they range so much in personality type, background, age, skill set, what their approaches are, the kinds of systems that they're targeting. They're as varied as you could imagine. Really quick summary though. Black hat is a hacker doing evil. White hat is a hacker doing good. Gray hat is a hacker hacking. Top hat is a hacker doing fancy stuff. That's a really basic summary of the way people often describe them. This could be a whole talk in and of itself, but essentially a black hat hacker they're hackers with malicious intent. White hats are hackers who find vulnerabilities in systems sort of with permission. They've been hired to look at that sort of thing. Gray hat is they're potentially poking around without permission, but they inform the companies and let them know that there's a problem rather than exploiting it for a malicious purpose. And there's lots of nuances and there's crossover with this, but at a really basic level, those are kind of the three types of hackers that we have. But the one thing that they all share in common is they are clever, they are creative, and they are curious. Curiosity is a common trait amongst a lot of security folk. It's the constant thought of like, what happens if I do this? What happens if I press that button? This sign says do not enter, but the door's open. What happens if I go inside? That curious nature combined with a creative out of the box approach, it leads to some really clever solutions in how they do things. Often it doesn't have to be because, again, this is a talk about the common pitfalls of developers and the sorts of mistakes that they make. But these sort of three things allow those attackers to exploit and leverage those mistakes for some interesting purposes. So why would a hacker do it? What do they seek to gain from it? What are they trying to do? It could be financial. It could be that they want to install ransomware on your computer and get you to pay them X number of Bitcoin to get the decryption key so that you can get all your files back. It could be a reputation. That could just be for bragging rights on the internet, or it could be something like a HackerOne type reputation system where they're looking to progress up a leaderboard. And it could be corporate reasons, and that's not necessarily corporate espionage. That's not one corporate sort of entity trying to infiltrate another one and send in the spies, as it were. It could be corporate reasons because you're a penetration testing company who's been hired by someone to test the boundaries, test the barriers, see what kinds of things you can find. It could be ideological reasons. These things could be political, they could be social, they could be that someone just disagrees with what you do. The Westboro Baptist Church is a very extremist, outspoken church in America, and they were protesting. They were going to be protesting victims of a school attack, and Anonymous hacked them live on air because they just disagreed with what they were doing. And it could be that someone stumbled upon something. This doesn't have to be people specifically targeting you. There are so many scanners out there that just search for open services and botnets and scripts that you can download that just do everything for you. And they just might happen to stumble upon something. They just got lucky. Ultimately, it's sort of focusing on what makes you a target. And for the most part, a lot of people sort of go down the route of like, we're going to be hacked for this, that, and the other. it's probably not going to be some elaborate state-sponsored attack where you're infiltrated by spies from another country that are seeking to, steal your latest intellectual property and all that sort of thing. That's probably not going to happen unless you work for a very small set of companies. It's anything that's popular, you're a target. If you've got a big data set, more data, more visibility, you're more popular than someone else, you're probably more of a target than them. Again, politics and perspective, they might disagree with what you're doing. Hacktivism, as it's known, is a thing that's growing and doesn't seem to be slowing down anytime soon. It could be the people in your organization make you a target. And that's not necessarily that someone is particularly being attacked themselves. An example I like to give is there was a company in America who, during a routine security audit, noticed that there was a lot of VPN traffic coming into their network from China, which was very unusual, shouldn't have been happening. Once they dug down and investigated, it turns out that one of the employees had outsourced their job to China for a much lower fee than they were being paid in their salary. So effectively, they outsourced their job to China, let the Chinese developers log into their VPN on the corporate network to do the work they did, paid them a small sum of money for it, and then spent the day browsing Reddit and YouTube and eBay. So that's someone that's opened up a network to an external entity into their corporate network, not for malicious intent, but who knows what could have happened from there. And again, potluck, it could be that someone stumbled upon something. Automated systems, bots, scanners, tools that are scanning the internet and particular things, looking for certain search terms, that kind of thing. That makes you a target. But the biggest thing is quick wins. Not only what are the quick wins that attackers are looking for in order to infiltrate your systems, but what are the quick wins that you as a developer can put in place to help mitigate against that? What can you do to start reducing the risk? Now, notice the key word here is reducing. It's not eliminating. You can't eliminate all risk. You can reduce it, and you can do your best to reduce your visibility or your footprint if that's something that you might be able to do. But realistically, you're not going to want to reduce your visibility because people want to be out there. It's about promotion and marketing. You can't hide yourself away. There is no magic solution for this. There's no magic fix-all. It's not a silver bullet and we're hunting werewolves. It doesn't work like that. There's no magic fix-all, and security is an attitude. It's not about sort of getting to the end of a project and saying, you know what, well, let's make it secure now. It's an approach that everyone needs to have and a mindset that everyone needs to have through the entire project workflow. That means that when you're discussing it at a specification stage, when you're having implementation discussions, including security tests in your CI pipeline, for example, and ensuring security requirements are a consideration of your acceptance criteria for a particular feature that you might be building. Just in the same way that making sure that, when an entity is saved to the database, for example, after you've clicked save and whatnot, making sure that someone can't view that entity if they're not meant to. That's something that should be considered in this sort of thing. It's everyone's job. It's not just the developers who are building the system after it's been built to then go, you know what, let's make this secure. A tutor from mine back at university, who works in the cybersecurity department, put it better than I ever could. And it's that, no one has the time or money for securing their systems until it's too late. You go to your bosses a lot of the time and you say, we need to secure this, we need to do that, we need to consider this as part of the software. And they say, we haven't got the time or money for it. But as soon as you get breached, you can guarantee they'll give you all the time in your world and write you a blank check if they have to, because they want it fixed. But the problem is that attackers use this to their advantage, because by the time you know about it, it's too late. And you can't go back in time and fix it. By that point, it is too late. There is no stopping the problem. The data is out there. It's already leaked. You're just in damage control mode. And it's every developer's responsibility. I mentioned it's everyone in the project's responsibility, and I wholeheartedly agree with that. But it's also every developer. If you're building a system and you know that there's a particular thing wrong with it, it's your responsibility to raise that and do something about it. Because if you don't, you're just as complicit in the, well, it's fine, no one will ever do that. Thankfully, on our platform, we've not had anything major so far. We've had some pen tests done by some very, very talented up-and-coming sort of junior, teenage-level cybersecurity researchers as part of a UK-based program. They found some really cool stuff that we never would have thought of. It was great. We learned a lot from it. We don't take any kind of report as a threat. It's if someone says, here's a problem, we are grateful and appreciative of that. And it's every developer's responsibility to make sure that you're aware of that sort of thing. So I mentioned the people problem earlier, and this is, by the end of this, you might start thinking or feeling or thinking that I feel like I'm a bit of a tinfoil hat person, don't trust anyone. I'm very much not like that. But the reality is that people are a fairly big weakness in organizations. It's unfortunate, but that's the world that we find ourselves living in. And in the, movie hacker style dream, you'd build $1 million supercomputer cluster to crack it because it's, using really high bit encryption. In reality, just drug them and hit them with a wrench until they tell you the password, because the weak part is the person. So following something called the principle of least privilege is a really good approach to make sure that not everyone has access to everything all the time. Basically, the principle of least privilege states, give people access to the bare minimum they need to do their job, and only for the time that they require. Do it. So, for example, I don't have 24-hour access to production database. I don't need it. It's just limiting who has access to what. It doesn't mean nobody has access to anything, because then nobody could do their job and the system would fail. But do your devs really need 24/7 access to your production database? One of your developers might, because they are in the support role, and they're logging in if the database goes down in the middle of the night, and as part of your SLAs you need to make sure it's up and running. They might have access to that. But the reality is that you might not need access to it. You could generate access as and when you require it. A friend of mine, David Mackay, posted some really good sort of insight to it, was that no developers should ever have permanent login or access to any credentials. And that's not to say that a break glass button in an admin interface somewhere can't generate a production database login that's valid for an hour, so you can log in, do what you need to, and then log back out. But it could log who requested it, take a reason, and notify everyone that that's happened. And especially with things like chat ops, that's becoming more and more appropriate. You go into Slack and, type a message to generate you a login, and it alerts everyone to say, hey, Matt's just requested a login for production database for an hour. Here's the reason why he's asked for it. Here's what he's typed. That then means that people can look at that and go, that seems really weird. Matt's just asked for a production login to the database at 2:00 in the morning, and it says because reasons. I'm going to investigate that. But if I've just got 24/7 access, there's nothing to say that I couldn't just be doing that anyway, and no one has knowledge of it. So don't give people unchecked access to everything. Consider who needs access to what and for how long they need it. So when we're looking at that sort of thing as like data storage, like where is your data stored? Is it on a cloud server somewhere? There's that famous sticker that's there's no such thing as a cloud. It's just someone else's computer. And yes, that is true. It's just someone else's computer. But what sort of connected data stores are you using? Are you using caching systems or file systems? Are you, Redis or S3 for file storage, because that's one of the most used ones out there? What about where your code is stored? Is it in GitHub or Bitbucket or GitLab? And there's valuable information in all of those sorts of places. And then people say, yeah, but my MongoDB database is secure because no one would ever leave it exposed with hundreds of millions of records in it. But the reality is that sort of thing can happen and does happen. So when people say, yeah, but my data is secure, it's all fine, no one would leave it exposed because that's just a silly thing to do. Well, not really, because it happens quite a lot. So then we're looking at well, if we're using these cloud data stores, who are the third parties that you trust with your data? If you're running a company, you might be using something like Slack for chats, or Microsoft Teams, or is it HipChat, the Atlassian one, if anyone ever actually uses that? Are you posting confidential information in there, pasting passwords around, for example? What about Google? Are you using Google Docs to type things up? Amazon, your data is stored on their servers, for example. And sort of the point here being that it's not the data necessarily, it's that attackers can leverage the trust that you have with those particular platforms in order to get to what they need. And it's not necessarily that, it's third party. It's where not your data, it's not your customer's data, it's the third party that it's stored on, be that the servers or whatever it might be. And again, making sure things like S3 buckets, that's the data that's stored there. You've got to make sure that third party, they don't care if your bucket's exposed, because that's just part and parcel of the config, for example. You need to make sure that sort of thing is set up. For a while, there was a bunch of Trello boards that were public rather than private, because people hadn't realized that they needed to set them up as private rather than public. And they had some random URLs, but if you could guess the right URL or get through to it somehow, they were running a project or a particular event, and they were pasting their Twitter passwords in there, for marketing communication and that kind of thing, not realizing that board is accessible by anyone who can get to it rather than a specific lockdown set of users. So that's a third party that's not responsible for that, but you're using their platform. So you have to make sure you understand how that platform is implemented and how it works. So then we get to, how do you trust them with your customer data? Because your data is one thing. Your customer data is a whole different kettle of fish. With things like GDPR coming in, customer data is something that you need to protect just as much as your code and your own data. It can't just be treated as, the customer data, that's not ours, we don't care about that. That's, as far as I'm concerned, should have been the approach that everyone has from the start. There are a number of questionable companies that haven't had that approach from the start. So GDPR forced them into that role. But with everyone complaining about how difficult GDPR was to do, in reality, if you were doing things properly anyway, you didn't really have anything to worry about. So these sorts of exposed data stores that I've been talking about, where you could potentially be misconfiguring things, to be able to find that sort of thing, you can use a tool like Shodan. Now, effectively, Shodan is a search engine that lets you find specific types of computers online. So you can do with a variety of search terms and search facilities, you can effectively go to Shodan and do a search and say, find me all of the exposed MongoDB servers that you know of on the internet. And it will find them, which is both amazing and really, really scary. If you ever want to sort of see what it finds about your personal home network, put your own IP address in and see what it's scanned. That can be quite fun to do sometimes. But effectively, all it is it's a search engine for things that it's found on the internet, and it will tell you metadata about the particular instance that it's running on. So if you're running an old, exposed, and vulnerable version, and it returns that version number, someone can use that to say, hey, they're running an old, vulnerable version of MySQL that's exposed to the internet for some reason. So that's an approach for them. It's a fun tool to play around with. There's a paid version for the full search facilities, but it's an interesting tool that opens your eyes to just what is exposed and what is available out there online. But fundamentally, as I kind of mentioned with the GDPR stuff about like protecting data and whatnot, the biggest thing that you can do is don't store data. You can't lose what you don't have. If you don't have it, it can't be lost. Nothing to worry about. For example, with the that US site that went down, Parler, the recent one that was used for the Capitol riots and the sort of the storming of the Capitol. When you uploaded photos to that website, it didn't strip metadata from photos that were uploaded. So geolocation information was all uploaded with the photos. So now they've got that stored on their servers. And if they ever lose it, people can use that data to pinpoint where photos were taken at what time and start to map out the routes that people took around. That sort of thing is, those pictures were publicly available. So if you have that sort of data and you lose it, there's big ramifications for that sort of thing. If you don't have it, you can't lose it. There's nothing to worry about. For example, in our platform, we don't store anything that we don't need. The only information we have about a person is name and email address, because we have no reason to have anything else about that individual. We don't need anything else. We don't need dates of births. We don't need pronouns that they go by or what their gender is, anything like that. We don't need it because it's not relevant to our interests on a platform. So why have it? If we don't have it and we did get breached, then we're not losing that data. In the OWASP top 10 is sensitive data exposure, which is something that's big in the OWASP top 10 list, which is the top 10 list of vulnerabilities found in web applications. So if it's on that list, its chances are it's a thing that's affecting a lot of websites and a lot of systems out there. Where possible, encrypt data at rest and encrypt data in transit. That should just be done anyway. Let's Encrypt makes it so easy to HTTPS all the things these days. It's free. It can be automated. It's so simple to do with Let's Encrypt these days that there's not very many excuses out there. So we've looked at where people could be the problem and where data could potentially be a problem. But one area that people don't necessarily consider in a lot of places is your repositories. Now, a lot of people will use an externally hosted version control system, GitHub, Bitbucket, GitLab, that kind of thing. And at some point in your Git history, there might be a commit in there that contains a secret. You might not know it. It might have been deleted since then, but the commit might still be in place. And unless you've rotated those credentials, they could be considered breached. So you need to look for these sorts of things in your repository. Your repository might contain secrets. It might contain passwords and API keys and that kind of thing that you're not aware of. One of my favorite examples of this was years and years ago on Reddit. Someone posted a thread saying, hey, I've created a new website and it's uploaded here. And here's where the repository is hosted on GitHub, and I'd like any critique of the code and this, that, and the other, and it's quite a nice looking website. And about 10 minutes later, the website homepage was updated to just say you need to update your, you need to remove and update your FTP details in your repository. And someone then posted a comment saying, hey, in your repository in an early commit, you've got a commit that shows your credentials. You've got a file in there that shows your credentials. You need to remove that file. You need to change those credentials because they are now compromised. So this person posted a comment, oh, yep, will do. Changed the site back to how it was, removed the file, went back in to Reddit and was like, yep, cool, that's done now. And about 5 minutes later, the site was updated to say, no, you haven't, because they'd removed the file, but not changed the secrets, and the commits were still there. And even if they'd have removed the commits by squashing them and rebasing or doing anything like that, someone locally with a copy of that has still got a copy of those secrets. So they hadn't gone through and rotated those credentials that had been breached. They'd just hidden them and gone, oh, well, they're hidden, so no one will know about them anymore. So searching for that sort of thing, there's actually a tool that can do that. It's called Git Leaks. You can point it at a repository and it will list out, here's the things I think I found that could be secrets within your application. You should go and take a look at these and make sure that they aren't actually credentials that are being leaked. So then if we've got secrets in our repository, there's the potential that that code is uploaded to our public site and is publicly visible somewhere. That's the sort of thing that some people don't necessarily realize that's taking place, but you can actually find that sort of information on Google. It's called Google Dorking. And effectively, it's using Google to find leaked public information. And it's just using searches on specific file types for strings within that file type. So for example, if you go to Google and do a search for db_password file type :env, it will find you all env files uploaded to public sites that have a db password parameter in them. Some of them might just be local testing versions. Some of them might not be. But that's the sort of thing that you can do with Google Dorking to find out what sort of information. Combined with your own site URL, you can search your own site for this. Which leads us into a type of intelligence gathering called OSINT, which is public. This stands for open source intelligence. And all it means is this is data that's given freely and publicly. The previous stuff might not want to have been given freely. You know, an env file committed to a repository in a live site, you don't want to give that freely. It's available publicly, but you might not have wanted to give it. This is the information that people are legitimately saying, I'm putting this out in the open, not realizing that if you gather enough of this information from all over the place, you can actually do something with it and start building profiles on people. So it's using sources that are open, not necessarily about open source software. It's not related to open source software or collective intelligence. It's just about using a framework which has a useful website to sort of pinpoint stuff through to start searching about information on a person or a company for that kind of thing. But it all comes back to that curiosity. What if? What if I change this value? What if I search for this particular thing on that website? What if I see if that repository's got any leaked secrets in it? What if? Because most people don't consider that. They just take it at face value and assume that it is what it is. What if I don't trust user input? Because users intentionally or otherwise don't always do what you expect them to do. The commonly recurring exception we see in our application is during the sign-up process, we ask a user to verify that they are who they say they are. And we pass with their email address and some security token information, we pass a UUID along for a particular user. And we see it all the time in that the target of people on our platform are specifically hackers. They are people who want to start tinkering with stuff. And we see it in our logs of, hey, they've changed the UUID value of the user to see if they can get access to someone else. They can't. We've got that bit locked down, but we find it really entertaining when a log pops up and we're like, hey, look, we've got another one, because we shouldn't trust them. And it's not even necessarily that the users are trying to do something malicious. In that example, they're trying to see what they can do. They're logging into a CTF platform that they're going to be using to compete against other users. They're going to want to try and give it a little poke and see what they can find. But that's not even what causes problems for a lot of people. Years ago, I got a message from a recruiter that I'd used in the past, and naughtily, they didn't have an unsubscribe link in their email. So I clicked on the link to go through to the website to see if they had a contact form, because I was going to send them a message. And I entered the message, I'd like to be removed from the mailing list, please. And as I submitted the form, I was popped up, a stack trace popped up in front of me, and it had an error screen stating that SQL was invalid, and it dumped out the SQL for me, and there's no prizes for guessing what caused the problem. That wasn't me trying to break the system. I was just typing an English sentence, and I'd used an apostrophe, and they weren't escaping their queries. They weren't using prepared statements. They were just taking the string that was entered in the contact form, appending it to some SQL and executing it on the database. I then emailed them a different message, making sure to not use any punctuation, informing them that they need to fix it, and they should do so before someone malicious does something bad with that information, because with the right query, you could either delete their whole database or get their whole database, probably getting it before deleting it for someone who wanted it, and sent the email off and didn't hear anything back. So sent the message off on the website, didn't hear anything back. I went back to the website 6 months later, tried the same message, the error was still there. They clearly didn't care enough. All the messages on that just go to an email inbox where they're not replying, or they're not monitoring it. But that's the sort of thing that comes up where this sort of thing seems obvious to seasoned developers. Well, of course you use prepared statements. You'd be surprised how many people forget that and don't do it. So prepared statements is very simple. The query and the data are sent to the database server separately, and that, I'm not going to go into the details under the surface, but effectively that fixes the problem, because the problem of SQL injection is the mixing of the code and the data. It's when you put data into your code and execute it, you're then trusting that data to be valid, and you're executing it alongside your code. That data could have come from a user, and that's very, very bad. And it might seem obvious to some, but injection is still a thing in 2021. And I future-proofed this slide earlier because I realized that I've given this talk in 3 different years, and every year it's still there. So ad infinitum, SQL injection is going to be #1 in the OWASP top 10, because who knows? I don't think it's ever going to go away, because it's a problem that's existed for a long time. There's a lot of websites out there, and it's going to stay there. So I've just made that slide future-proof. So we don't trust the data of users, but we also shouldn't trust data in general. If data's come from a third party and you trust it, well, that data from that third party could have come from a user. For example, there was a Whois website that you could go in, type a domain name, hit lookup, and it would provide you the DNS records of the domain name and give you all the information about it. One developer realized that this website wasn't escaping the output from the Whois lookup. So they added a TXT record that would embed the YouTube video of Rick Astley Never Gonna Give You Up and autoplay it when it was displayed. So if you went and did a Whois lookup on their domain name, it would pop up the Rick Astley video and rickroll you. That site since then fixed the problem, but that site had assumed that, well, it's a TXT record, what's the worst that anyone can do? But with that, they've managed to find a cross-site scripting vulnerability in your application and could have done a whole lot worse. So it's not just about trusting user data. It's don't trust data that comes into your system, even if it's from a third-party API. And along with that, if we're not trusting data, don't just validate client side, which is a thing you see a lot of websites doing these days, or even mobile apps. They just assume that the only way to get to the back end is through the front end of the website, be that a mobile app or a website, a HTML page on in a browser. But you can send requests to that backend if you know what it is. And that's the sort of thing that if you're validating only on the client side, then you're basically just, like a sign saying, keep out or don't, I can't stop you, because there's nothing stopping you just avoiding that and going straight to the backend. You see it in mobile apps quite a lot. the cause of so many problems is that they do the validation on the client side and then send it to the back end. But there are so many tools to observe that traffic that goes from the client to the back end. And if you can observe that traffic and you realize that there's no validation being done on the back end, it's just assuming that any data sent from it has come from a valid source. Well, then you can just send your own payload in, and in doing so, just bypass all the validation and do whatever you want. So we're not trusting people in our company. We're not trusting users. We're not trusting the user's data. We're not trusting data itself. We're not trusting our front-end clients. There's not many people we are trusting here, but don't worry, because those that do have access to things might end up with actually some broken access control, which used to be called in the OWASP top 10 insecure direct object references, but it's now been merged with a couple of other bits and pieces, and it's now called broken access control. Basically, what it means is, if you're allowing access to things in your application, are you checking that the right people have access to that thing? This is basically making sure, does the user accessing this have access to do so? You've probably placed an order on a website in the past that's got, orders, order equals 1, 2, 3, 4, 5, 6, and it's passed in the order ID. We've all seen a URL like this at some point, but do you trust that value? Because a lot of orders still use auto-incrementing IDs. So what happens if I change that by 1? Do I access that order? Now, in an ideal world, I shouldn't be able to access that order if it's not mine, because I don't have access to it. It's for someone else. It could leak potentially sensitive information like their address. I shouldn't be able to access that. But you'd be surprised how many systems out there assume that if you've got the valid ID, you're able to access it. And that's not the case. So now we're not just trusting user data. We're not trusting users. This is like paranoid face, tinfoil hat time. Don't trust anyone. Go live in a cave. Give up development because it's all fire and brimstone. But in reality, it's not actually that bad. People will do bad things. They will try bad things. People will inadvertently break stuff without realizing it. You've just got to make sure that, again, you take those basic steps. A good place to start is the OWASP top 10, because whether your users are malicious or not, you cannot trust them. We were in, I don't actually know if my team leader is in this call, by the way. He's watching the talk, I think. But we were at a work meeting. We have a company meetup a few times a year, and we were doing an escape room. And this is a team where on my team were a couple of people from the security team. There was a couple of developers and a couple of people from I think like support and marketing. But we were in this escape room, and we got through to the second part of the escape room, and we needed a 4-digit code to exit the room and get out escape the room and beat the speed time. And someone found, through solving a puzzle, they found the first 2 digits of the code to exit and get out of the room. At which point, one of the security people said, right, you carry on trying to find the second half. I'm going to go to the keypad. And they went over to the keypad and started with those 2 digits at the start, but then just started with 00, 01, 02, 03 at the end. They got to 15 and the door popped open. And the person behind the door was like, that was really quick. You did really well. And they just kind of gave him a sly grin, because ultimately we'd just brute forced our way out of the escape room. It was quite fun, that one, because that was just an example of they hadn't quite thought through that if you've got a 4-digit code and you give someone the first 2 digits, the most combinations there is on the last one is 100. So if you start working your way up the list, eventually you'll hit it. And there was no brute force detection or prevention on that. So we were just allowed to do that. They probably weren't expecting people to do that. They were expecting people to play within the spirit of the game, but they had a team of security researchers in the room. So really, what's going to happen? So we're now looking at, if we're not trusting users, what about authentication? Because authentication is something that exists within most web apps. There are very few web apps these days that aren't trying to get you to sign up for an account so they can spam you with emails over and over again. And authentication is a thing that's been around for a long time. I have no issues saying that the very first authentication system I wrote in PHP was so horrendously bad, and I'm sure we probably all did the same thing. I stored the user ID in the cookie that was sent to the browser because I just assumed that if you had the cookie, you were the right user. So if you went to any of the sites that I built back in early 2000s, maybe, these were hobby projects, and changed the cookie to ID 1, you'd be logged in as the admin, because obviously the admin is user number 1. That was years and years ago. My team lead would fire me if I did that these days. But a lot of people still get authentication wrong. And this is not just small companies. the link at the bottom of this slide takes to a really interesting article from Nissan. They've got a car called the Nissan Leaf. It's an electric car, and it had an app that you could log into. And the app would then allow you to control the car itself. So you could turn the heating on in the morning before you got out there so that when you got into the car, the windscreen was already defrosted, that kind of stuff. Cool, great idea. Unfortunately, the way that the app worked out what car it needed to talk to was by using the vehicle identification number. And if you had the vehicle identification number, you could talk to that particular car. And the vehicle identification number was printed on the window of the car. So if you walked up to a Nissan Leaf, looked at the window and got the number, you could then make API requests to turn the heating on and control the car. So this isn't just small companies. This is Nissan. You know, they're a global car manufacturer, and even they get it wrong. So the big one that people come down to is like password hashing. Either passwords aren't hashed or they're hashed with the wrong algorithm. You need to do it properly regardless. PHP makes it really easy to do hashing well. I had a friend who wasn't the biggest fan of PHP, to put it politely, but when they found out we had a really good password hashing API and a couple of really good functions that made it easy, they were like, oh, that's really good. I wish I had that, because the language they were working in didn't make it easy. We've got it quite good in that regard. The password hash, the password verify, and the password needs rehash function, I think it is. They make stuff like that really easy. Bcrypt is an algorithm that you can use that you can set a cost parameter on. It can be rehashed with a new cost. It does it all for you. It sorts out the salts. It makes sure the strength is okay. As long as you're using a high enough cost, it just makes it really, really easy relative to a lot of older systems and other systems. It goes without saying, don't use MD5, don't use SHA-1, just use Bcrypt or Argon2 or the PBKDF. What is another one? There's a few of them that are really good, but Bcrypt is a safe bet. And obviously don't use default passwords. And I say the word obviously there, but again, apparently Equifax can't even get that right, because they used a combination of admin as the username and admin as the password for one of their systems. And that's what led to the 2017 enormous data breach that affected many, many people's credit reports, and they were forced to put credit protection on a whole bunch of people and give them stuff because they failed so royally. And again, this is Equifax. This is a big company who apparently should get everything right, but even they got it wrong. Don't use default passwords. Admin password, admin 1 2 3 4 5 6, and any number of thousands and thousands of others. They're really easily guessed. And don't reuse passwords. In 2018, LastPass and LogMeIn ran a survey, and they surveyed, it was only 2,000 people, but it's a decent sample size. And 60% of those people were reusing passwords across accounts. And of those, 60% were reusing passwords for both work and personal accounts. And almost 80% of those people in total had between 1 and 20 accounts online. So if a site gets breached, it's not about necessarily whether you are hashing passwords correctly. You could be hashing passwords using an amazing algorithm that costs tons and tons of CPU time and no one's ever going to brute force it. But if you let someone use the password, and they've had that password breached in a previous data breach with an email, then someone could obtain that breach, use that email address and password on your system, and they will log in as that. It's called credential stuffing, and it's an increasing threat and problem to our systems. And the more breaches there are, the more passwords get leaked, and the more accounts become vulnerable. And broken authentication is number 2 in the OWASP top 10. So there's a multitude of ways it can be broken, and credential stuffing is a very big one of that list. Cool. Have I Been Pwned is a website run by a chap called Troy Hunt. He's an Australian security researcher, and you can enter your email address into this website, and it will tell you what data breaches you've been in. It won't print out your password. It won't leak any of that data. It will just tell you whether you were in a breach for that particular website. You can sign up to notifications as well. So when you end up in another breach, because it's not a case of if, it's a case of when these days, really, you'll get an email saying, hey, your data was leaked in this other system, because it's the internet these days. I'm in over 20 breaches at this point. I can't control that. I signed up to those websites and I'm in those breaches. So, hey, it is what it is. The reality of it is that if I'm using secure and unique passwords, and I'm, as part of the system, we're not allowing users to reuse passwords. It doesn't matter if a password is leaked on another website, because our website can't be breached if we're not allowing them to reuse passwords. So, for example, this is an MD5 hash of a password. How could we crack it? There's a tool called Hashcat. There's John the Ripper. There's tools where we could spin up, as earlier, $1 million cluster to try and brute force this hash and try and break through it and see what it is. Or the reality is we could just Google it. This is actually the hash of the password. So if you've got an MD5 hash, chances are it's been found somewhere if it hasn't been salted. So if we're not allowing users to reuse passwords, we can use a system called the Pwned Passwords API, again, provided by Troy Hunt as part of the Have I Been Pwned sort of ecosystem. What you do is you SHA-1 the password and you send the first 5 characters of that hash off to the API, at which point it returns all the passwords, also hashed with SHA-1, that match that particular set of 5 characters, along with the number of times that they have been seen in any breaches. If your full hash is in that list, you can then say, this password has been reused before, and not allow them to use it. Some people have said, that doesn't sound secure. You're sending, SHA-1 hashes and this, that, and the other. You're only sending 5 characters. You're not sending the full hash. You're getting back a much bigger list. And that blog post actually details, it's called the K anonymity model. And it's a model that's been developed as part of Cloudflare stuff as well. There's a really good write-up on how and why it's secure. And it's a model that makes a lot of sense. So you can actually stop users reusing passwords by using this Pwned Passwords API as well. Again, another one of the systems we can use for authentication is multi-factor authentication. Multi-factor authentication is not something that's new to a lot of people. They just don't realize they've been doing it before. It's also, two-factor authentication is using 2. Multi just means using 2 or 3. It's often the 3 things: something you know, something you have, and something you are. The R is biometrics. It's your face scan, it's your fingerprint, it's behavioral stuff, which is an emerging thing, but not particularly reliable at this point. But multi-factor authentication is something that people have been using for years without realizing it, with chip and pin. The chip is something you have, and the pin is something you know. That's using 2 factors. When you go and take money out at an ATM, you put the card in and then enter your pin. The card is something you have, and the pin is something you know. Email address and password, it might be 2 pieces of information, but they are not different things. They are both things you know, so they are single factor authentication. So multi-factor authentication can be used in a lot of platforms. More and more platforms are using it. I believe it might be Mailgun, the email provider. There was a provider somewhere that basically said, if you enable multi-factor authentication on your account, we'll give you a discount on your bill because you're taking proactive security measures. So the one-time codes that you get on your phone via an app, they're multi-factor. Often you'll get an SMS from any number of companies that do that sort of thing. I don't particularly like SMS. It's great from a widespread standpoint because it's considered these days that everyone has a phone that can receive SMS. How true that is, it's debatable. There are people that don't have phones, but everyone knows what an SMS is who's got a phone. So it's easy to distribute to a wide number of people. The problem with SMS is it's really easy to spoof. It's really easy to hijack SIM cards from people if you want. So I don't particularly like it. But if you're looking for widespread access, it's better than nothing. So now we don't trust users. We don't trust data. We don't trust their passwords. We don't trust our people. We don't trust our systems that we're on. What about other people's code? Because we run our own code on our servers, but there are packages upon packages upon packages that are in our applications. You would probably have across your entire software stack more packages than you think. When you consider we've got front end, possibly mobile apps, back end, we've got the platform that we're using, the infrastructure that it's running on. If the front end is using a number of JavaScript libraries and then mobile apps are using packages, back end, by the time we hit the sort of bare metal server, we could have potentially thousands, if not tens of thousands of different software packages across our system. Now, no one can be expected to keep up to date and know how to patch every single one of those things ourselves, because we're not experts in the languages that cover 10,000 different packages across our software stack. But the biggest thing we can do to protect against potential vulnerabilities that come in play is just keeping them up to date. Because the biggest thing is a vulnerability is released. Ideally, the team behind the software is alerted. They roll out a patch for it. You update, you're no longer vulnerable. The biggest thing you can do is just keep things up to date. Because in security, there's no such thing as absolute security. Sometimes it's one big thing that leads to the breach, but in reality, it's more like death by 1,000 paper cuts. It's come to mean something that's a slow process. It's not one big thing, it's multiples and a multitude of small little things that by themselves aren't big, but when you've got 1,000 paper cuts, it results in your untimely demise. Your web of trust is much, much larger than you might think. Now, this is not to say that you reduce your web of trust to just you. It's just that every time you add something new to that web of trust, you need to be cognizant of what the impact of that is. Now, mistakes will happen. This is an inevitability. No one is perfect. Again, security is not absolute. It's not, nothing is 100% secure. It's an attitude. Mistakes will happen. But you just need to make sure that you don't miss the simple stuff. Chances are that you're not going to be the target of a state-sponsored attack. Chances are that you're going to forget that you set up that admin portal with admin as the username and password, and someone used that to log into it. Or you had the password written down on a post-it note on your monitor and a visitor came in and saw it. That's a bit more convoluted. It's happened. You think of the number of BBC interviews that people have done in offices where there's been post-it notes on the monitors behind them with the access credentials of things. Don't do that. That sort of thing happens all the time. There's a number of police forces that have done it before, a number of large corporations, and they then scramble to change the passwords because they've just broadcasted them on national television. I'm really sorry. It's not like the movies. It's not like typing on a magic keyboard and shapes are flying around you in the air and you're in a room with fancy lighting that's flashing and going off and big graphical interfaces. It's not like that. The expectation is this, frantic typing, and the reality is a lot more boring. It's unfortunate, but that's just the way things are. There's a number of steps you can take. You need to evaluate who you trust with your data. Security at all stages of the project, it's everyone's concern. It's not just the developer at the end that's told, right, now make it secure, because by then it's too late. Follow the principle of least privilege and make sure that not everyone has access to everything all of the time, only the things that they need to do their job when they need to do it. Encrypt your data in transit and at rest. Check your public sites for secrets, be that public sites, public repositories, even secret repositories, because just because it's behind a login doesn't mean it's necessarily secure. Don't trust users and input. Tinfoil hat time. Don't trust anyone. Hash your passwords properly. Don't let people reuse passwords. Ensure your components aren't vulnerable. And if you want a checklist of things to look through, the OWASP top 10 has been, will be the #1 resource for web application sort of security vulnerabilities, because those are the top 10 things that they find. So those are the 10 most common things. Those are going to be the 10 things that everyone's looking for because they are the most prevalent across the internet. So if you go through that, that gives you a starting point to start looking at what to address. But the #1 thing to do is always be curious, and thank you very much.